Hello Precalculus student, this video is for chapter 3.6 part 4, solve polynomial inequality. In 3.6, our main goal is to solve polynomial zeros, and this last part will be kind of an application of solving polynomial zeros, because after we solve zeros, they actually can be used to solve inequalities. So the steps that we follow to solve polynomial inequality, if they are nonlinear, right? So if it's a linear, you already know how to do it in pre-algebra or algebra 1. So let's go through the steps. First, you write the inequality as an equation and you solve the zero. So this is what we have been doing. And then you arrange the zero in increasing order. Now you would not write the answer right away. After you have those zeros, you would not say, oh, they're always greater than, so you won't say that. If 1 and 2 is the answer, you would say x is greater than 1 or x is greater than 2, like that. So those zero actually are used to divide your number line into test intervals, and then in each test interval, you pick one number to check if the inequality is true. The solution is the union of all the intervals where the inequality is true. So remember, the zeros, 0, 1, 0, 2 are used to actually cut the intervals into parts. And sometimes we call it critical number, sometimes we call them key numbers. So for example, we have a inequality here. It is not linear, and we want to find the solutions. So solutions are intervals. So we would arrange all the numbers. So that means rearrange the inequality, so everything is on one side. After this, then we will change it into, we will find zeros. To find zero, we would actually have to do try to factor this equal to 0. So notice that to find 0, we change the inequality into an equations, and these become it's easy to factor, -3 and -2. 1 times -3 will multiply as -3, and when you add them is -2. So our factor is x plus 1 and x minus 3 equal to 0. So because of that, x is equal to -1 and x is equal to 3. So then we use this to divide our number line into -1 and 3. Notice the order. Negative number or the small number is on this side. And then we do test interval. So in the interval from -infinity to -1, we can test x is equal to what is less than -1. We can test x equal to -2, and we plug it back into the original inequality. So this actually can be factored as x plus 1 and x minus 3. Is it greater than 0? So this is the inequality that we'll be testing, right? So this is the one that we'll be testing, because after we move everything over, so to test if it's positive or not, we can just plug in -2, -2 plus 1, -2 minus 3. So they're both negative. So yes, it is positive. This is true, right? And then from -1 to 3, we will test. We don't test the equal. We don't test the one that is on the interval, because we know it's a 0. So we'll test 0, right? So 0 plus 1, 0 minus 3 is negative. So greater than 0 is false, right? It's not true. And then the last interval is from 3 to infinity. 3 to infinity. So we will test x equal to x equal to 4. So you will plug in 4 plus 1 and 4 minus 3. So this would be always positive. It's true. So our answer is those intervals that make the inequality true. -infinity to -1, union 3 to infinity, and that's how we find the answer. The answer is so this 2. Sometimes we do it this way. This is not. You just write the answer that way. The second one is similar. So we'll say we didn't solve this. So we'll say, well, actually move everything to one side, minus x minus 20 less than 0. We are testing for something that's less than 0. So first of all, we find 0 first, right? X minus x squared minus x minus 20 equal to 0. Also can do by factoring. Negative 20 and negative 1. So of course it's 5 and 4. So it becomes x minus 5, x plus 4 equal to 0. So in this case, it's x is equal to 5 and x is equal to negative 4. So this would be used to do the test number. So we have negative 4 and 5. So what should we do? We test negative infinity to negative 4. And we're testing this particular expression x squared minus x minus 20 is factored as x minus 5, x plus 4. So, but it's less than 0. So we would do we test x equal to negative 5, negative 5. So negative 5 minus 5 and negative 5 plus 4, both are negative. So, but want it to be less than 0 is false, right? It's not right. And then we can test from negative 4 to 5. This interval contains 0, so we'll say we test 0. 0 minus 5. So it's easier. You see how it is easier when it is in factor form to test. You could put it back here to test or put it back in the original to test. But if you use a factored form, you just need to check if it's greater than 0 or less than 0. So it's a negative number and this is a positive number, is less than 0. It is true, right? True. And then the next one would be test anything that is over here from 5 to infinity. We can test 6, right? Test x is equal to 6. So 6 minus 5 and 6 plus 4, both are positive. To be less than 0 is false. So the only one that works is between negative 4 and 5. So our answer is negative 4 to 5. Now, if your original inequality called for less than or equal to 0, you would use the square bracket. But if it is just greater than or less than, you would exclude the 0, exclude the equal to. The third one is a cubic inequality. So let's try to solve it. Everything is already on one side, so we just solve zeros. So zeros. So we'll say 4x cubed minus 6x squared equal to 0. We obviously can factor 2x squared out, so it will be 2x minus 3 equal to 0. X is equal to 0 and x is equal to 3 over 2. So we have two zeros only. 0 is smaller, 3 over 2. So we divide our number line into intervals and we choose test point. But we want to be less than 0. So negative infinity to 0. We test negative 1. So you will have 2 times negative 1 squared and 2 times negative 1 minus 3. So you can see that this is a negative number. So this works, right? So it's true. And then we test 0 to 3 over 2. We cannot test 0 because it's already in the boundary. So we can test 1 because 3 over 2 is greater than 1. So 2 times 1 squared and then 2 times 1 minus 3. So this one is negative. That is a positive. So it's still true. So both of these intervals work, but not exactly equal to 0. And then we test 3 over 2 to infinity. So we can test anything we want. We can test 2, right? So 2 times 2 squared and then 2 minus 3. Of course, this is less than 0. No, this is false. This one is actually a negative number. So this is doesn't work. So the answer is from negative infinity to 0 and then union from 0 to 3 over 2. Now, in case this is a less than or equal to, you could take 0. So you would have one interval. Okay. Example 3, solve this. 3x cubed minus x squared minus 12x greater than or equal to negative 4. So we would need to find 0 first, right? Or before that, we would actually changed it over, so it becomes 3x cubed minus x squared minus 12x plus 4 greater than equal to 0. So this is a greater than. So let's find 0 to solve. 3x cubed minus x squared minus 12x plus 4 equal to 0 to find the key points. So this is 4 term. So we try groupings. It seems to work, right? 3 and 1. This is 12 and 4, which is 3 times. So maybe it would work. So factor x squared out. I have 3x minus 1. Factor minus 4 out. I still have 3x minus 1. So it does work. So our answer would be x squared minus 4 and then 3x minus 1. Can we factor more? Yes. X minus 2, x plus 2, and then 3x minus 4 equal to 0. So in all cases, we have x equal to 2, x equal to negative 2, x equal to 4 over 3. So these are the 0. We'll use it to divide our number line into 4 intervals. The smallest is negative 2, and then 4 over 3 is the second, the largest is 2. So we have 4 intervals to test. So I'm going to test negative infinity to negative 2, and I'm going to test which point should I do. What negative 3, right? So and I will test this, right? Test this is greater than 0. So negative 3 minus 2, negative 3 plus 2, 3 times negative 3 plus 4. What do we have? Oh, it is a minus 4. So this is negative, this is negative, this is negative. Are they all less than 0? Is it greater than or equal to 0? That's false, right? And then we could test the next one is negative 2 to 4 over 3. 0 is inside, so we will test 0. So 0 minus 2, 0 plus 2, and also 3 times 0 minus 4. So these two are negative. So this is positive, negative, negative. Yes, when we multiplied it, it is true. And then the next one would be 4 over 3 to 2. So in between them, so this is 1.3 and this is 2. So let's test 1.5, right? So 1.5 minus 2, 1.5 plus 2, and then 3 times 1.5 minus 4. 3 times 1.5 minus 4 actually is positive. But 1.5 minus 2 is negative, so it is still negative. So that is false. The last one is anything that is from 2 to infinity, right? So we will test, run out of space, test 3, right? 3 minus 2, which is positive. 3 plus 2 is positive. And the last one, 3 times 3 minus 4, of course, is positive. All positive together, greater than 0, true. So our answer would be, maybe I'll write answer here, okay? The answer would be, we say this is okay. This one is okay, but not this two. So the answer is, and we have equal in the middle, so we would say is negative 2 to 4 over 3, including the endpoint because they are equal to 0, union a square, including 2 to infinity. So that is the answer. So just remember, when you solve polynomial inequality, you spend your time to solve the zeros, but the zeros are for number line, dividing the number line into test interval. Choose a test point in each interval to test for if it satisfies the inequality. Usually we would use the factored form to test inequality. If it's not possible, you can use the original inequality test also.